Hey there, welcome back to my channel. Today we'll be doing this question that is on Leetcode, move zeros. And let's get right into the question. So the question statement states that given an integer array nums, move all zeros to the end of it while maintaining the relative order of non-zero elements. And we need to note that we need to do this in place without making any copy of the array. So let's understand this question statement better with the given example right here. And the example states that we have been given this nums array, and we need to make sure that all the integers that are non-zero, be it negative or be it positive, whatever be it, are at the front, and the relative order is maintained. The relative order means, let's say if this was my given array, then if -1 is coming at first, it will stay at the first, and then if 1 is coming second, then it will come second, and if 2 is coming third, it will come third, and 0 will be appended at the last. So this is what we mean by making sure that we keep the relative ordering maintained. Now let's understand the intuition behind this problem. Now, at first, we need to think about how can we even solve this problem using a brute force approach. Now, just think about that we don't have any constraints or anything. Now, it is very simple. In brute force approach, what we could do is we can make sure we go through every element. We go through every element and we push into our array. Let's say we have an array of empty size. And what do? We go through every element. We see if that is a zero, we don't do anything, and we just keep a count of the zero. Let's say this is a counter which will track how many zero do we have in our original array. So if we have a zero, we just make sure we increment the count. Next we go, we see this is one, so we push the integer into our array. Now we go and we see, okay, there's one more zero, so increment the counter and subsequently move forward and keep on inserting. So at the end of the day, what do we see? We have two zeros, so we insert two zeros, and this is what our answer would be also. But they have said that we must do this in place, because here, even though we are making sure that we optimize the time complexity and making sure that it is a one pass solution, we are utilizing an O of n space. So this is not to be done in an interview. We need to make sure that we do it in place and O of one space. So let's understand how to do this in the best possible manner. So now, okay, so let's just take a random example and then we can write on this, and that will make your intuition for the optimal approach, much more clearer. So let's just take this as an example. Now we'll see. So what was our condition? Our condition was that if wherever I am at is not equals to 0, I will perform some operation. And what is that some operation? That is, I will make sure nums of j is equals to nums of I, and we increment our j by 1. Now why do we do this? Again, try run this and it will be very clear to you. So this two pointer approach is basically very intuitive based solution. You just need to make sure whatever operation you are doing, you understand what you are doing here. Now at first, what do we have? We have I and j at the starting point. When I and j are at a starting point, what does it mean? That is -1 is not equals to 0. Do we do anything? Yes, we make sure that nums of I equals to nums of j and we increment j by 1. Now if you see, if we do this, it doesn't change our array, and all we do is we just increment our I and j. Again, this is a non-zero element, move. Again, this is a non-zero element, move. Now, when we are here, our I moves by 1, right? Now we see this was not a non-zero element. This was 0. So this condition, that is plus plus j, that is j incrementing by 1, will never be executed, and our I will only be moving forward. Now at the next index, this is a very crucial step. So our next time when I is at a non-zero element, it will see that, okay, this is a non-zero element. I have to make sure whatever is at I, it goes to j. And as you can see, this is what it does, isn't it? And our j moves by 1. So j is here. Now again, I will move here and it will see that, okay, this is a non-zero element. So what do? We just make sure whatever is at I, we keep it at j. So it will come like this. So at the end of the day, we will have our array to be like this. And how many zeros? We are making sure that we keep a counter of 0, right? So it will just say that we have 1 0. So at the last index, what do? Whatever value is set, replace it by 0. And this is done. Run through of how to do this question. Now let's get to the code. Once you dry run this 2 or 3 times, you will get a hang of it, because two pointed approach is just about intuition. And once you know the intuition, it will be very clear to you. Now let's get on to the code part. At first, we make sure we find the size of the array. And as discussed, we will make sure we keep a counter for the number of zeros that are present here. So we will initialize this to 0. And let's just count how many zeros are present in our array. So we will just keep a simple check. If the id equals to 0, what do? Make sure the count of 0 is incremented by 1. Now, as an optimization step, we could do that if the count of the 0 is equals to 0, then we just simply return. And why does this help? Let's say if our array does not have any zeros and it is of, let's just say, very large size. Let's just say if the array is of 10 to the power, let's just say 9, then what are we doing? We are saving a lot of iteration, because whatever operations that we are going to do here, that will be skipped, because we know for a matter of fact that there is no 0 here. So why even do this? So that is there. Now coming to our actual solution, we make sure we go here and we put this. So this is a simple loop right here. What do? Now coming on to the main part, as discussed, what are we going to do? We are going to make sure that at any instance, if we find it is a non-zero element, then what do? Yes, we just swap the elements at j and swap the elements at I. So let's declare the variable j as well, or let's name it a better variable name, index to be swapped. And let's just copy this here as well. So what are we doing? We are just making sure at any given instance, which is a non-zero element. So let's say if our array is something like this, at first I and j both are present at the same index, and it swaps it, and I and j both move to the next index. This finds that, okay, this is a zero based element. What do? We just make sure I moves next, and at the next instance, what do we see? That, okay, 8 is not zero, not a zero based element. What do? We make sure I and j are swapped. So it is not exactly swapping, it is just assigning whatever the value at ith index to j. So that is why I'm saying swapping, but sorry for that confusion, but it is not exactly swapping. We're just making sure whatever is at I, we just keep it at j. Now what do? I moves forward and j also moves forward. Now we know that we were keeping the count of zeros, so at the end of the day, we make sure whatever count of 0 are there, so we iterate from back and make sure we flip that to 0. So that is what we are going to do now. So after this is done, we make sure we just flip those number of elements to 0, back to 0. So let's do this. Flip equals to, as we are starting from the end, we make sure we do s is -1 because we are starting from the end. And now what do we have?
go back flipping until the count of the 0 is greater than 0, and we just decrement this, and nums of flip equals to 0. So what this will basically do is go to every value and make sure the number of elements or the number of counts of 0 that were present there, you flip those. So our final array would look something like this. So what are we going to do? Since we know that we had 1 0, so we will flip the last element back to 0. Okay, so let's just add the semicolon right here. And also we missed one more part here, that is nums of flip minus minus. Why do we need to do this thing? Because at any given index, let's say if we had two zeros in our array, that is something like this, and our final array would look something like this, isn't it? Now if we are starting from here, we know that the last two indexes should be 0. So if we are starting from here, we need to decrement the count to go here as well. So that is why we need to put a minus minus here. Now it does not matter if we put it here or we explicitly do something like this, that is this. Both are equally good, and it doesn't matter on the performance much, so we can do anyway. Okay, so now let's just submit this, and this should get accepted as well. Yep, this is getting accepted, and yeah, this is it. Now for the time complexity, if we go through it, all we are doing is we are traveling the array first time, and then the second time, and then the third time, which is max O of 3n. So this is our time complexity. Obviously we can reduce the number of passes here and bring it to O of n, but this O of 3n solution is regarded as the best solution. You can obviously flip some passes here, that is this count of 0 that we are counting, we can make sure that we keep it here only, and which will obviously work. So we can do it in O of 2n passes as well. So if you want that solution, just comment down below, and I'll submit that solution here as well.